Okay, here we go. Chapter 1, Lesson 1. Our objective here is to use inductive reasoning to make conjectures. So, first we need to know what inductive reasoning is. Inductive reasoning is reasoning, so like a way of deciding something, based on patterns you observe. So you see something happening, and you decide, I think that this is going to happen again because I saw XYZ happen. Okay, a conjecture is a conclusion reached using inductive reasoning. So if you use inductive reasoning to come to an answer, that answer you have chosen is a conjecture. And last but not least, a counterexample is an example for which the conjecture is incorrect. So if you come to an answer using inductive reasoning, and then somebody says, well, that's not right because in this situation it doesn't work, that is a counterexample. So if I say any number plus 2 is always an even number, somebody would say, well, 1 plus 2 is 3, and that's not an even number. That'd be a counterexample. Okay, let's check out some examples. Finding and using a pattern. Find a pattern for the sequence. Use the pattern for the next two terms in the sequence. So we've got 384, 192, 96, 48. So we're dividing by something every time. Well, if I take 384 divided by 2, that'd be 3 divided by 2 is 1. We'd have 18 left. 18 divided by 2 is 9. We'd have nothing left. 4 divided by 2 is 2. That'd be 192. So I think we're dividing by 2 there. Okay, 192 divided by 2. Well, 19 divided by 2 is 9. We'd have 1 left. 12 divided by 2 is 6. So it works there. So I think the pattern is that we're dividing by 2. So each term is half the preceding term. The next two terms are 48 divided by 2 is 24. 24 divided by 2 is 12. So there are your next two terms, 24 and 12. Okay, let's check out a second example. Using inductive reasoning, make a conjecture about the sum of the cubes of the first 25 counting numbers. Find the first few sums. Notice that each sum is a perfect square and that a perfect squares form a pattern. So 1 cubed, well, there's nothing to add there, so 1 cubed is 1, 1 squared is 1, which is the same as if you just said 1 squared. 1 cubed is 1, 2 cubed is 8, 1 plus 8 is 9, that's the same as 3 squared. Here we've got 1 cubed is 1, plus 2 cubed is 8, plus 3 cubed is 27, so 27 plus 8 plus 1 is 36, which is the same as if we did 1 plus 2 plus 3, which would be 6 squared. Okay, so what we're trying to figure out is what's the pattern. The sum of the first two cubes equals the square of the sum of the first two counting numbers, right? Because we've got 2 cubes. If we would add 1 plus 2 first and then square it, we get the same answer, 9. The sum of the first 3 cubes equals the square of the sum of the first 3 counting numbers, because we've got first 3 cubes. If we did 1 plus 2 plus 3 and squared it, we'd get 36 from both things. This pattern continues for the 4th and 5th rows, so a conjecture might be that the sum of the first How many are we trying to figure out here? Well, up here it says the first 25 counting numbers. So the sum of the first 25 cubes equals, think about how this is written, the square of the sum, we're copying it from up here, we used this before, equals the square of the sum of the first (25) again, first 25 counting numbers. So we took the pattern that they found up here in these first two sentences and we extended it to the next 25, the first 25 counting numbers. Okay, testing the conjecture. The first three odd prime numbers are 3, 5, and 7. One pattern of the sequence is that each term equals the preceding term plus 2, right? 3 plus 2 is 5, 5 plus 2 is 7. So a possible conjecture is that the fourth odd prime number is 7 plus 2. Well, 7 plus 2 is 9. However, because 3 times 3 is 9, 9 is not a prime number, this conjecture is false. The fourth odd prime number is 11. Okay, there's an example where your guess didn't work out. Applying conjectures to business. The price of overnight shipping was $8 in 2000, $9.50 in 2001, and $11 in 2002. Making a conjecture about the price in 2003. So first, in 2000, they charged $8. Then they charged $9.50. And then they charged $11. Well, when we went from $8 to $9.50, we added $1.50. When we went from $9.50 to $11, can we add $1.50 there? That equals 11. So the price increased by $1.50 each year. The possible conjecture is that the price in 2003 will be increased by $1.50. So if this is true, 11 plus $1.50 is $12.50. So that's our guess. We think in 2003 it's going to cost $12.50. Okay, what you need to do now is try these 4 check for understanding problems. We've got number 1, where you're finding the next 2 terms in each sequence. Number 2, we're going to make a conjecture about the first 35 odd numbers. Here we've got a critical thinking problem. And last but not least, we're going to go back and apply it to business again. So use the examples that we did together. Try to do these next 4 problems. When you get to class, check in with me on them.